Hello guys, so today I am going to discuss about the tree data structure guys. So it is this section is the most important and most joyful section ever in the full of DS algo. Tree is the most important part of DS and algorithm. So I am going to say about the basic of tree data structure and all of the parts of data structure, types of data structure, advantage or disadvantage of data structure. I think your concept will be clear after this video. See it carefully and see it full video. So in at first it is the most important things that what is the tree data structure. You can see that the what is the tree data structure. A tree is a non-linear data structure. It is a most important thing that tree is a non-linear data structure compared to array, linked list and stacked and queue, which are linear data structure. Okay guys, in my previous videos I also upload videos about stack, queue, linked list, all of arrays and all of linear data structure I also uploaded in my previous videos. But it is the most important thing, tree is a non-linear data structure. I say quite later that why tree is the non-linear data structure. So now a tree can be empty with no nodes, or a tree is a structural consisting of one node called the root and the 0 or 1 or more subtrees. So I'll be going to explain briefly the tree data structure. So tree data structure mainly you can see that it is the main frame of tree data structure. And guys, you can see that this is the main, or it is the starting node. So it's called the parent node. It is at first which is the first node of the tree or main, the starting nodes, that's called the parent node. And here you can see that the it's are divided in the two parts, and this is the child node, because of that this it is the parent node and this is the two part of this parent node. That's why that's the child node, and also that's the child node, and these two are the child node of this parent node. So guys, it can be you can elaborate or spread this tree in infinity times. So it's your so here you can see that this is the thing you can elaborate or spread it for infinity times. And I show here it is the 1 2 3 4 steps. And in a data tree, in a data or in a bunch of data, it says the thousand or millions or billions of subtrees are available there. So it is the very simplest and very smallest tree structure here. So now I'll be coming in types of data structure, which I'll be going to discuss fully and briefly. I think I made a separated video in all of the types, because the tree is the at first type tree data structure is the most important data structure. And that's all of types are contains the various parts, or it's have many it's all have many subparts. So I also made some separated videos in tree data structure, types of tree data structure. At first, the types of tree data structure, at first it is the general tree, and second is the binary tree, third is the binary search tree, and fourth is AVL tree, and 5 is the red black tree, and 6 is the n array tree. So guys, the most important tree is the general tree, binary search tree, and AVL tree. So it's all of the most important, but it is also a part of tree data structure, but these four are the most important or most useful for tree data structure. So now I'll be coming in the advantages of tree data structure, or benefits of tree data structure, so you can see that the here will be understand the advantages of tree. At the first advantages, I here written the most important advantages here. So at first, tree reflects in the data structural connections. The tree is used for hierarchy. Okay, it means that a hierarchy means the you know about the family chart, I think. So here in family charts is the maintain that the hierarchy, it is the hierarchical peak of tree. And then you can see that the it offers an efficient search and insertion procedure. So I make a next video, or quite later I make a separated video in insertion and deletion of tree data structure. So don't worry about that. And it is the last advantage, or you can say that the I here listed the three advantages, but you can find many advantages in, you can search in Google or any search engine, So at third point, the tree are flexible. This allows subtrees to be reallocated with minimum effort. Okay, so that's all of the advantages of tree data structure. And I said a quick wrap up, which is the this is the main structure of tree data structure, or trees look like that type. And in tree data structure, we have a 6 type of tree data structure, and I'll be going to briefly elaborate all of the parts. So at first I'll be going to general tree. So guys, at first you can see that the general tree. So what is general tree? If number constant is placed on the hierarchy of the tree, a tree is called a general tree. Every node may have infinity numbers of children in general tree. The tree is the superset of all of the other trees. So here it is said that the all of the parent trees can contains the infinity times of children trees. So it hasn't any limit, because of that's a non-linear. Okay, so then if number contains is a place on a hierarchical in a tree, because of tree is a hierarchical, it maintains the manner of hierarchical structure. And in next there is the binary tree, and it is the most important tree. Binary tree and binary search tree is the most important tree. So what is the binary tree? The binary tree is the kind of tree in which the most of two children can be found for each parent. The kids are known as the left kid and the right kid. This is the more popular than most other trees. When certain constant and characteristics are applied in a binary tree, a number of others such as AVL tree, BST tree, RBT tree, etc. are also used. Sorry. So here I want to elaborate this binary tree. Here I point in black color. You can see that it is the main part of this definition. Two children can found for each parent. Here is a foundation, or you can say that the disadvantage, that the two children can be found for each parent. It is a foundation, because of any parent node can only contains the two child node. You can see that the model or the binary tree structure. So you can see that here is the A node, and in the child node, that is the B and C is the child node, A is the parent node of BC. And now the child node also contain the two nodes, that is the DE and FG. Or yeah, it is the structure of binary tree. Here it is the two children can be found of each parent. It means that it is the parent, and it is the two children. A is the parent and B C is the child or children. And then when B is the parent, D and E is the child node, and in the C, F and G is the child node. So it is a foundation that a parent node also contain two child node. So now I want to come in binary search tree, or the most important tree. So at first I want to say about the binary tree for your better concept about the binary tree. I know that's the quite long, but binary search tree is the most important tree. That's cause I written the more information in this definition. So binary search tree or BST, binary search tree is a short form which called the BST. Binary search tree is a binary tree extension which several operation restriction. The left child value of the node should in BST be less than or equal to of the parent value, and the right child of the value should always be greater than or equal to parent value. I also elaborate or fully briefly discuss about this part. This part is the main part of binary search tree. So this binary search tree property make it ideal for search operations, since we can accurately determine at the each node whether the value is the left or right subtree. This is why the search tree is named. So here you can see that the structure of binary search tree. You can see that the value of the parent node is 8, and then you can see that the value of the child node is 3 and 10, 2, 6, 14, 4, 7, 13. You can see the difference here. You can see that the here it is the 3 and 10. It is not a random value. It is also created by it's not created by default. It is created intentionally, because binary search tree has a rule that all of the right tree have the greater value, and the left subtree have the less value. So you can see that there's a 10 is the bigger value than 3. So here it is written the left child value of the node should the less than or equal to parent value, and the right child always should be greater than or equal to the parent value. So now it is the 8, it is the parent value, so it is the right node. Right node is 3 and left node is 10. Because of it is 10 and it is 3, it is the less than the 3 is the less than of parent node, and 10 is the greater than of parent node. And here is the 3 and 10 is the now 3 and 10 is the parent node. So here it is 2 and 6. So 2 is the less than the parent node, and 6 is the greater than of the parent node. And as usually 4 and 7, here 6 is the parent node. And then 10, you can see that it is the left node, and left node is also the bigger value, also contains or backing the bigger value now. So here it is written that it is 14, and when this parent value have right, it's also have a right tree, so it contains 13. It means that always the right value less than the parent. 14 is the parent here. So video is going very long or more timeable, so it's I think it's going quite boring for more time. Actually, I made a short video or separated video on types of tree data structure. So see all of the tree data structure parts. Because of it's not a very short part, it has a vast knowledge or vast of things. I also describe about the all of the codes of binary trees and binary search trees in separate videos. See all of the videos, and in next videos I also say about the more of things or most of the most important things of tree data structure. So see the all videos, and if my video is helpful, please like, share and subscribe. Goodbye.